Welcome back to our fractions, and we are now up to part 2. So we talked about last time about fractions of 1 and the LCD, the least common denominator, all our simplifying rules. So now we're going to get down to, we're going to put in this box here, we're going to write same denominator rules. And I'm going to put these signs right here because what we're going to do is we're going to talk about adding and subtracting. So if you want to put plus minus right there, that's what that means. It doesn't mean positive and negative. We're talking about adding and subtracting fractions because remember, fractions is what we're focused on. Okay? So what we're going to do, we're going to open up our book where we left off at. And we're going to go to the top. And the top up here is going to hold our steps, okay? So here we go with our steps. So step number 1, when the denominators are the same, these are so easy. Step 1, keep the denominator. Okay, that's step 1, okay? Step 2 is going to be add, subtract the numerator. Step 3 is going to be simplify. And we just, if you watch the last video, you'll see that we talked about simplify. And it's going to say if possible, because sometimes it's not possible to simplify, but we always have to check. So these are our steps. It seem pretty simple, but I'm going to throw a couple more things at you, okay? And for adding and subtracting to make things easier for you. I'm going to tell you to always work vertically. And what I mean by vertically is I mean this direction. If you work going up and down, it helps to change denominators and do all kinds of things if we're working vertically, okay? Second thing to always remember, it has to do more with subtraction, but it's borrow using fractions of 1 when needed. Okay, so you want to do that, okay? And the last thing, oops, there we go, so you can see it a little better. And the last thing to think about in our rules is to simplify improper. We're going to talk about what an improper fraction is in a second. Simplify improper fractions into mixed numbers. Okay, so you want to simplify improper fractions using mixed numbers. So let's talk about what that looks like. Okay, first of all, an improper fraction. This is an improper fraction. When the numerator is larger than the denominator, that is called improper. It is not a proper fraction. So that's what that's called, an improper fraction. In 8th grade, we leave everything improper. It's great. But in 7th grade, we have to learn how to, we have to remind ourselves how to make things into mixed numbers. Okay? So we know that this becomes 1 3/8. Okay? So you would think about it. How many holes can I get? If I have 11 pieces and I need 8, every 8 make a hole, I have 1 hole and I have 3 left over. So we have to remember that. We're going to come back to this improper mixed number idea a little bit later, but we have to understand the words. We have to understand the terminology or we can't do this. Okay? All right, so let's take a look. Those are our steps. So let's go down here and let's do an example. We're going to do 4 examples this time. So example number 1, 3/8 plus 2/8. Now remember, we're working in this one, it's the same denominator. So we're just going to follow our rules. So step 1 says keep the denominator. So they're both 8, so I'm going to keep that denominator. Then step 2 says add and subtract the numerator. So this time we're adding, it's an addition problem. So 3 plus 2 is 5. Pretty simple, 5/8. Okay, simplify if possible. Well, 5 and 8, that's as simple as it gets, so we're pretty good. We're done there, so that works out really well. Let's go over here to example 2. 3/16 plus 1/16. Okay, once again, denominators are the same because that's what we're working on. We're going to keep the denominator, which is 16. we're adding. So 3 plus 1 is 4. So now we have to look at simplifying. If it's possible, 4 and 16, is it possible? It is possible. They're both even, right? So we could divide both top and bottom by 2, but I'm hoping that you see there's a larger number that goes into both 4 and 16, and that's 4. So we're going to use the fraction of 1 of 4 over 4 so we don't have to work so hard. And 4 divided by 4 is 1. 16 divided by 4 is 4. So the end result of 3/16 plus 1/16 is 1/4. Okay, moving on down, we're going to do a couple. Those were our addition examples. Let's do a couple subtraction examples. So example 3 is going to be 5/8 minus 1/8. It's following the same procedure. We're going to keep the denominator of 8 because they're the same denominator. Then we're just going to subtract the numerators. 5 minus 1. Well, 5 minus 1 is 4. And once again, these are both even, so we know that 2 can go into both numbers, but we also know 4 can as well. So we're going to use our fraction of 1 of 4, and we're going to put it in here. 4 divided by 4 is 1, and 8 divided by 4 is 2. Okay? And we're going to do one more example here. Okay, so one more subtraction example. It's going to be 2 and 1/8 minus 1 and 5/8. Okay, so we're going to use all of our rules this time. Okay, we can keep that denominator of 8 because they have the same denominator, but if you only have 1, I can't take 5 from you, can I? You have 1, I want 5. I want to take away 5. So that's not going to happen. So what we have to do, it goes back to our rule up here. If you're going to borrow, use a fraction of 1 when needed. Well, guess what? We're going to need a fraction of 1 here. So I'm going to borrow 1 from the whole number, and we know that every whole is 1 like that, right? 8 over 8. That's one whole, isn't it? So I'm going to borrow from the whole number and put it over here. So when I put it together, I find out that this is now 9/8. Knowing that this is 9/8, now I can do some subtraction. Now you have 9, I want 5, that gives me 4. And then 1, take away 1, well, that goes to 0. So now we're down to this 4/8. And again, once again, we have to simplify. Seems like I picked all the ones that use a 4, which is okay, because we just want to understand how it works. And then 4 divided by 4 is 1, and 8 divided by 4 is 2. So hopefully that helped explains our same denominator rules.